Hello, this is the fourth part of the Chapter 16 video, and this is all about hearing, being able to hear something, and then the anatomy associated with it. So the purpose of the ear is to detect sound and head movement. It directs those things to the vestibular cochlear nerve to be able to have conscious awareness of it. The first anatomical part that collects the sound waves is called the external ear. Another technical name for that is the auricle, and its job is to direct sound waves inward. When the sound waves get in, they go into this area. This area is called the external acoustic or auditory meatus, also referred to as your ear canal. And it's going to go all the way until it meets your tympanic membrane that I just hit. Now, you probably are well aware of that in this canal that there's earwax in there. And the earwax is produced by glands called ceruminous glands. And the wax itself is called cerumen. It's a modified sweat gland. And the reason why we have earwax is to protect the middle ear from getting infected with microorganisms, possibly. This is a view of the tympanic membrane. So once sound waves get through the canal, they reach the tympanic membrane. And this is like a drum, so it's nicknamed the eardrum. And it meets where the partition, where the external and middle ear meet. And when sound waves hit it, it vibrates, it moves, and it transmits that sound wave energy to the middle ear. So the ear, this canal, and the eardrum are all part of the external ear, and their job is to direct the sound waves inward. The middle ear is after that point, and it includes the three internal ear bones and the eustachian tube. What separates the middle ear from the inner ear is two areas called the oval window and the round window. So in the middle ear, there's another tube. This tube is called the eustachian tube or called the auditory tube. Usually it's closed, and it's a passageway that extends from your ear into the back of your nose, your upper throat, called the nasopharynx. When you have middle ear infections, they're called otis media, and they usually result from infections in your nasal cavity that spread through the throat and up that auditory tube, and the fluid and the pressure will push on the eardrum. Like I said, that tube is usually closed, but yawning, chewing allows the air to move through it to equalize the pressure of the tympanic membrane. The ear bones are called the malleus, incus, and stapes, MIS, and the job of these bones is to concentrate the sound waves into the inner ear. So the malleus is nicknamed the hammer. It passes the sound waves to the incus, and its nickname is the anvil, and it passes the sound waves to the stapes. And the stapes is connected to the oval window, which is the beginning of the internal ear. And like I said, their job is to direct the sound waves, and they also amplify. They amplify the sound waves 20 times, make them 20 times stronger. You have muscles that are attached to your ear bones. They're called the tensor tympani and the stapedius, and they attach to those bones and they prevent loud sounds from hurting our ears permanently. They work pretty good, except if that sound is very, very strong and very, very fast, like a foghorn can damage the ears, the hearing. Here is the malleus, the incus, and the stapes, and these are the muscles that are attached to them. Once the stapes passes the sound waves to that oval window, it's now in the inner ear. The inner ear is made up of two nesting containers, one within the other. The bony labyrinth is on the outside, and it's maze-like, and it contains a fluid called perilymph. And it fills that space. So perilymph is within here. Within my fist, this is the membranous labyrinth, and it's filled with a different kind of fluid called endolymph. And within here, the membranous this is where we have your receptors that detect sound. There are three main regions within the inner ear: the cochlea, that looks like a snail. It contains the cochlear duct. There it is, the snail. The vestibule, which is this area in the middle. Between the two, I'll take it out. I can actually take out the inner ear. Okay, so this is the cochlea. This area right here is the vestibule, and it contains two areas called the utricle and the saccule. And then you have your semicircular canals. All three of these contain fluid within them that are continuous with one another. That endolymph fluid. It's continuous with each other. Oops. And this shows the three: cochlea, vestibule, and the semicircular canals. This is a great image that shows the membranous labyrinth, like my fist, with the endolymph, and the other areas, the bony labyrinth, has perilymph. Otitis media is a fancy word for an ear infection. It's an infection of the middle ear. A lot of times, younger children are more prone to it because their auditory tube, their eustachian tube, is more horizontal. And they're more prone to infections also. So an ear infection is just simply a fluid accumulation in the middle ear, pushing on that tympanic membrane, causing pain. And it can influence hearing as well. You view it with an otoscope where the doctors or will look into your ear and visualize it. And to treat it, it may require surgery. That's where they put tubes in the ears to drain the fluid. Hearing, cochlea. So a little bit more detail about the anatomy within the cochlea. So within it, you have receptors that detect or that will receive the sound waves, and then they will sense what is being said. So a lot of things going on. You're going to want to take a look in your image in your book too as well. But this is essentially where the magic happens. You have this opening called the scala vestibuli, and this contains the perilymph of the bony labyrinth. Below it, you have the scala tympani. In between them, you have the spiral organ. The spiral organ is where your sensory receptors are located. The extensions of these receptors have hairs on them. These hair cells are the receptors that sense and receive that information coming from the sound waves. I want to show you this picture. So here, all of the spiral organs and the different parts of the cochlea that can sense hearing, how it branches. This is just one of those areas. You can see this is the branch of the nerve. Okay, this is the top membrane called the tectorial membrane, and the basilar membrane at the bottom. And then in purple here, these are the receptor cells that detect hearing, and they have little hairs or extensions of it that extends into this essentially jelly stuff. Okay, so this is how you hear, putting it all together. Sound waves vibrate your tympanic membrane. They will pass those sound waves to the ossicles. Those are the ear bones. They'll pass it along to the oval window. The oval window will pass the message into your internal ear. The pressure waves from the sound will travel in that top area called the scala vestibuli, and they'll push on the membrane below it, on the endolymph and the fluid within it. And then specific regions will move in that membrane as a result of that pushing on the fluid. And different areas that vibrate produce different frequency, or different frequencies produce different amounts of movement. and at different locations. When that happens, the hair cells that are stuck in that fluid will move because it's moving. They'll move. And that will cause neurotransmitters to be released and a message to be stimulated, an electrical message. And the pressure will go away out the round window. So these steps, 1, 2, 3, 4, 5, okay, are the order of things that happen. So you check out that image as well.